Anne and Bella want to send some messages to each other, but they don't want anyone else to understand them. Luckily, Anne is a cryptography expert. There are two main types of cryptography: symmetric and asymmetric. Symmetric cryptography is when two people share a key, which is usually a very long number, that they use to both encrypt and decrypt messages. But there's a problem. How are we going to share a key in the first place? We can't just send it out in the open, and sharing it offline isn't possible. That's what asymmetric encryption is for. For example, the notorious RSA relies on everybody having two keys, a public one and a private one. Then you can share a key because one person can encrypt the key with the other person's public key, and that person can decrypt it with their private one. But there's an even better way. It's called Diffie-Hellman Key Exchange. It's a way for two people to create and share a key without ever transmitting it. Whoa! How does it work? Diffie-Hellman relies on modular exponentiation. Matthew word alert! Modular arithmetic is basically arithmetic around a clock. So 5 plus 8 mod 12 is the same as counting around a clock. The answer is 1, but modular arithmetic isn't just limited to mod 12 or 24, depending on where you live. Another important mathy word is coprime, which means that a given two numbers don't share any common factors other than 1. There are special properties of certain coprime numbers. For example, every coprime pair of numbers has a period, which is the smallest positive exponent that will get the number to equal 1 when modded. We call a number a generator when its successive powers go through every option. Now, back to our predicament. Here's what we'll have to do. We have to agree on a modulus, let's say 13, and generator g for that n, let's say 2. Now, we each have to choose a number privately, and we can't even share it with each other. I'll choose 6. I'll choose 4. Now we need to take the g, 2, and raise it to our secret number, mod n, and share our result. I got 12. And I got 3. Now raise the number I share with you to your secret number, mod n, and I'll do the same. Now, for the sake of example, share what you got, because I got 1. Me too, that is so cool. This isn't as magical if you realize that exponent rules are the same in mods, since it ends up being the equivalent of g to both of our private numbers. Now, why couldn't an outsider just find this out? Well, to do that, the outsider would have to solve these equations. This is known as the discrete logarithm problem, or DLP, and it is very hard to solve. In fact, the fastest way to solve it takes longer than a human lifetime, once n has about 100 decimal digits, so our messages are safe.